Hi, and welcome back to Network Programmability Basics. My name is Hank Preston. I'm a developer evangelist with Cisco DevNet. And in today's video, we're getting back into Cisco DNA Center Platform's APIs, specifically looking at how we can use those APIs to help us do network troubleshooting better. Now, this video is, of course, a part of the Network Controllers module for Network Programmability Basics. And in this module, we've already introduced the Cisco DNA Center APIs, as well as explored some of the applications and tools that are available through those APIs. There are also lessons in this module covering controllers like Meraki for cloud-based network management, or inside the data center with Cisco's ACI controller. Now, as always, if you want to follow along and experiment with this code and these examples, everything is up on GitHub in github.com/cisco-devnet/netprog_basics. For this video specifically, you'll want to take a look because we're going to walk through building a troubleshooting script, and that script is up on GitHub and you can take advantage of it yourself and look at it. Now, each one of our repos for each lab and lesson includes a setup README that shows you how to get started yourself on your own infrastructure. And if you need access to a Cisco DNA Center appliance, Cisco's DevNet Sandbox has them available in both always-on and reservable varieties. Now let's start off this lesson with a question. Can we use the Cisco DNA Center Platform APIs to make troubleshooting easier? Well, I wouldn't put the question in a video, particularly this early in a video, if the answer wasn't yes. Of course we can use the Cisco DNA Center APIs to make troubleshooting easier. Let's see how that works. We're going to start out by looking at a very common network problem, one you probably have several times a week, if not several times a day. We're then going to make a plan, a programming plan on how we can solve that network problem in a programmatic fashion. Then we'll walk through the process of writing the code to solve the problem. And at the end, we'll actually see it live inside a demonstration. So what problem exactly? Have you ever had a help desk ticket that looks something like this? The network is broken. I can't access the server, right? We see trouble tickets that look like this all the time. In fact, you probably have built yourself kind of a heuristic or a plan, a general approach you take whenever you see a network troubleshooting problem just like this. So our troubleshooting treasure map, so to speak, right? Our first step, identify the involved hosts. Which hosts on my network are being reported inaccessible or having problems? Once we know more information about those hosts, where exactly on the network are they? What devices do they connect to? What interfaces on those devices are they connected to? What path across the network do we take from start to finish? Every device along the way, layer 2, layer 3 information. Do we have to route? Do we have to switch? Where does this traffic go? Different areas where there could be potential problems along the path. This is the process we take to troubleshoot this manually, and this will be the same process we take to help troubleshoot this in a programmatic fashion. We take our treasure map and we begin to make our programming plan. Now, our goal is to create a Python script to execute the plan we just talked about. For every step along the way, we need to ask ourselves a few questions. First, what API can give me the information I need? Next, what details do I need to use that API? And then finally, what information am I going to get back from that API that I can leverage, either directly or to pass to the next step along our troubleshooting plan? So step 1, identify the involved hosts. Now, the API we're going to use in today's example is the host API. Now, a note about the host API. It is listed as a deprecated API for Cisco DNA Center Platform. The deprecation of APIs is a common activity as new features and APIs are introduced to platforms. And in this case, if you read the documentation up on Cisco DevNet about the APIs available, you'll see you're being encouraged to use the newer client API that's available in Cisco DevNet, in the Cisco DNA Center Platform capabilities. However, for this specific use case, the client APIs are not yet giving us the functionality we need. So we'll stick with the host API but we do know that we'll have to revisit this troubleshooting script in the future as that client API gives us the features that we're after. Now, the input that we'll use for the host API is the host name, the IP address, or the MAC address. Any one of these we can use to get information about a host connected to Cisco's DNA Center's network. That'll output the complete host information, including the network attachment point. What network device and what interface on that device is this host attached to? Step 2, where are they in the network? Now for this, we're going to be using a couple of APIs out of the Know Your Network category inside of the API catalog, specifically the network device and the interface APIs. Now to use these APIs, we need either an interface ID or a network device ID. Luckily, those are going to come back from the host API. This will give us an output. It'll show us interface status and configuration, as well as device details, like is that device currently reachable? Has that device recently rebooted? We can see that by looking at the uptime, as well as other details that'll come back. In step 3, what path is this traffic taking, right? We'll go back to the operational tools and then the path trace API to take advantage of path trace, the application that's part of the assurance capabilities from Cisco DNA Center. To use the path trace API, we'll need a source and destination IP address. We will have gathered this from the host information earlier in our treasure map. This path trace will then output the number of hops and the details per hop, the device type, the interface information. And then our final step, for every hop along the path, are there any problems that we can see? So we'll go back to that interface and network device APIs and explore information about the network devices, as well as the interfaces that are being used to ingress and egress each hop along the way, gathering us the full information about how we get from point A to point B across our path. With our plan in place, the time is now to write the code. Now, when we set down to write code for a project like this, we don't jump in and say, okay, we're going to write all of the code in one go. That is difficult to do, plus odds are good you're going to have to tweak and adjust your code along the way. It's best to do one step in your programming plan, test the code, make sure it's working as expected, and then move on to the next step. And that's how we're going to talk through this. First, we're going to do some basic preparation. We're going to set up our troubleshooting script. We're going to make sure we can gather input from the users. We want to make this script reusable, so we'll use the argparse utility that comes with Python to allow this to act as a command line utility that we can provide a source and destination IP address right from the command line. We can see that here in the parser.add arguments in our code. We'll then go ahead and we'll print out some basic details. So we're just setting stuff up. We haven't actually executed anything yet. We're just going to print this is what we've retrieved from the users so that we can show that we got the data correctly. And then finally in our preparation, we're going to go ahead and show that we can still log into Cisco DNA Center. Now we covered logging into Cisco DNA Center in a previous video, the Introducing Cisco DNA Center Platform APIs and Programmability. For a refresher, go back and check that video out. Now, if we run our troubleshoot prep script, the status at this point, we can see that we've gathered information and we've printed it out. Fairly straightforward, but it gives us a great foundation to build on. Step 1, identify the involved hosts. Now for this one, this is what we want to output. We want to give our script details to say, provide information about the source host and the destination host. What is the host name, if it's known? What network device is it connected to? What interface is it connected to? VLAN configuration, IP, MAC information, all of this different information. This is what we want to output. To accomplish this, we're going to create a few new functions inside of our troubleshooting script. We're going to create a host list function that we can use both on the source host and the destination host to retrieve information about that device based on an IP address that's given in our script. We'll then make sure that we only get one host back. It could be that we retrieve multiple hosts from Cisco DNA Center based on the one bit of information that was given. If that happens, we want to make sure our script ends with an error message that indicates that so that we can do some manual troubleshooting, because we don't need our script to account for every possible variation. just the majority of them, which is when we would get a single device back. And then finally, print host details function will take all of the information that comes back from the host via the API and prints out the interesting bits to the screen. Now our first function, the host list function, is going to take advantage of that host API. As a reminder, we're using the host API, but eventually we'll probably want to move to the client API for the script, as that API provides all of the details that we need. Now our function here, we can see our host list function supports taking input of an IP address, a MAC address, or a name, which means inside of our script, we have some if blocks that allow us to adjust our actions based on whether they're given an IP address, a MAC address, or a name as it goes through. And what we're adjusting are the query parameters that are going to be sent along with this request that goes through. Finally, we will make our request and retrieve the response and send that details back into our function for later steps to use. Specifically, the first step we'll take advantage of is the verify single host. We'll make sure that we didn't get 0 hosts back, indicating that we did not find an address or a host with that IP address, or that we get more than one. And again, if we do get more than one back, we want to exit our script and leave a message so that as our users can use that, know that they need to do a bit of manual work because the information they were given wasn't quite enough to hone in on a particular network host. With the details obtained successfully, our print host details function will take a host and then print out all of the information that we're interested in to generate that nice text display that we saw at the very beginning as we saw what our goal was here in step 1. And so we can see just a series of print functions where we're then pulling out details from the host that came back from the API call. If we run our script in this step 1 phase, we'll see that now we're getting back the host information. Here we can see on the screen details about the source host, but that would have been repeated for the destination host. But again, we can only fit so much on one slide. Now that we have our host information, we can move into step 2, where we learn where are they in the network. Now our output, right, we're going to tweak this a little bit. We're going to add some new information. We're going to add information about the source host network connection details, as well as the attached interface. Things like what device is it attached to, the uptime, the reachability status of the device. And then on the interface side, operational and configuration details that'll help us know if things look fine at the network attachment points. For this step, we have 4 different functions. We need to retrieve the network device information with network device list. We then print out the network device information into that nice, easy to read details like we saw on the previous slide. With the network device information underway, now we want to do the same thing for the interface details, and we use the interface details function to retrieve information about the connected interface for the source and destination hosts. And then once again, a print function prints out the interesting bits of information to the screen. If we look at the functions, here we have the network device list and interface details function. These will look like these are using the same APIs that we explored in the previous video on the APIs to know the network. And so we can see that we've got the URL for DNA intent API v1 network device. And then for interfaces, we're using DNA intent API v1 interface and providing identification information for both of these. We send these APIs across to Cisco DNA Center and retrieve the information that we're interested in. Our next 2 functions would print that details out to the screen in the format that we're after. And we can see here very straightforward string print statements where we just inject information from the API calls back into the output. When we run our script in step 2 version, we can see that we now have source host network connection details and all of the information there, followed by the attached interface details as well. We're getting quite close to the end of our treasure map, but now we need to figure out what path is this traffic taking across the network. For that, we're going to use flow analysis, also known as path trace. Now the output that we want looks like this. We want to run the flow analysis. We want to see how many hops does it take, and every hop along the way, the key details about it. For this, a couple of new functions. The flow analysis function will actually execute that path trace for us, given a source and destination IP address. And then the print flow analysis details will print out that nice format that we just saw on the previous screen. Now the function to actually execute the flow analysis is a bit more complicated than some of the ones we've seen previously because of the process that path trace takes. If you remember from the previous video on Cisco's DNA Center APIs, to execute a path trace, you first kick off the path trace, then you have to wait for that to complete and then retrieve all of the details using a separate API request. And that's what we're doing inside of here. We start out by making sure that we get back a 202 status code from the request. The 202 status code tells us that the initiation of that path trace was successful. If we get our 202 back, we can then go ahead and check for the status of that request with a while loop. The while loop is there because we have to wait for that status to come back as completed before we have the actual details necessary to process and operate successfully. Once we have that, we can return it back and then send it along to the print flow analysis details function. In here, a couple of pieces worth looking at. Inside the blue box, we have an if statement. The if statement is going to go ahead and throw out the first hop and the last hop. That's because the first hop is our source and the last hop is the destination. And we don't want to try to print information about those. Those aren't network device hops. In the green box, we can see that if the hop name is unknown, we're just going to move right along as well. This is because an unknown hop name indicates an unmanaged device to Cisco DNA Center. And if that device is unmanaged, then it doesn't make any sense to try to print information out about it. Frankly, our code would probably cause an error, so we just move right along. Here we're taking a look at the actual output of this script in its current state. Python troubleshoot step 3 with its IP addresses, and now we can see the flow analysis is run, 5 hops, including the source and destination, and then the flow details as it goes through. Now our final step along the way is, are there any problems along that path? We now know the hops that are being taken, but is there any problem in that way? This is actually a fairly straightforward addition to our script. Frankly, we're just going to make an adjustment to the print flow analysis detail function. What we're going to do is for every hop along the way, for every device and interface, we're going to go ahead and check the interface details for the ingress and egress interfaces and then print that out as well. So now when we actually run the script, what we can see is not just what the ingress and egress interface identification is, but we can also see all of the status information about that. We can see whether that interface is up. We can see the speed, the duplex, the VLAN information, everything that'll be necessary for us to understand whether this is functioning. All right, we talked through it. Now let's see it in action here in a live demonstration. All right, here we're taking a look at the full version of the troubleshooting script. We can see that we're starting out with our argparse module and then adding in arguments for source and destination IP address so that we can reuse the script for different sources and destinations. We then go ahead and just print out some basic information saying this is what we're going to run. This is kind of just a checkpoint so that we can make sure that we got the proper details. We'll use our DNAC login function to log into the device and then begin our troubleshooting process. Here was step 1 to identify the hosts using that host list function. Now we've already gone through all of this code in the slides, so let's actually run it and see what it looks like. So here I'm going to go ahead and run the Python troubleshoot full script, giving it the source and the destination IP addresses. We'll let this fully run and then take a look at the output. All right, the script is completed. Let's go ahead and scroll back up to the top and take a look at it. All right, here up at the top, we can see it outputted that information, just running the troubleshooting script, and then it gives us our source host details. We know that the source host is a wired client, its IP address, it's the IP address of the connected network device, as well as the interface that it's connected to. The VLAN information, IP, MAC address, and if there had been a subtype, we would have seen that listed. We see the same details for the destination host. After that, we move on to the network connection information. Where in the network is it? Here we can see the source host network connection details. So this device is connected to leaf 1. That's a Catalyst 9300 switch running code 1663, and that device has been up for 8 days. The interface it's attached to is Gigabit Ethernet 101, and that interface is both up and up, so things are looking pretty good at this point. We can see the VLAN it's attached to. We then see the same information for the destination host. It's connected to leaf 2, which is also a 9300 switch. It is connected to Gigabit Ethernet 10. Now we move into the flow analysis, looking at the path that we take across. We can see that there are 5 hops, but that includes both the source and destination. So hop 1, our first network device here, we can see that there's that leaf 1. We can know that the ingress interface is 101. It is up and up. We can see its VLAN information, and the traffic leaves leaf 1 on port Gigabit Ethernet 102. And we can see all of the information about this port. It is a trunk port. The second hop is spine 1, so we're moving from the leaf to the spine layer of the environment, and this is a distribution switch. We can see that its interface is also up and up, and it's a trunk interface as well. We leave the spine on 103, likely off to a destination leaf, and in fact, that's where we're headed. Hop 3 is leaf 2. We can see that it's an access switch. We came in on Gigabit Ethernet 103, and we're going out on Gigabit Ethernet 101, which is the final interface that connects to our destination. So in that demonstration, we can see how our troubleshooting script can gather all of the information we would have gathered manually through our treasure map, but it can do it much faster in a repeated fashion as it goes through. If we had actually gotten a trouble ticket that looked like this, we may have spent 20 minutes or maybe even up to an hour gathering all that information, logging into different network connection points, maybe checking spreadsheets for information about these devices. Whereas now that we have built our troubleshooting script, we can simply run it anytime we get a case like this. Now, in summary, we've gone through a bunch of stuff today. We reviewed a common network problem, in fact, one of the most common network problems, and we broke down the steps we manually take to solve it. We then saw how we could make a plan to tackle each step using the APIs available in Cisco DNA Center. We wrote the code one step at a time, testing it along the way, making sure that it was functioning effectively. And then finally, we just saw that script in action. Now make sure to complete the entire Network Programmability Basics course as we finish up this video here. We've got excellent resources from programming fundamentals all the way to Net DevOps to help you in your journey to become a network programmability master. Be sure to run these exercises. This script that we talked about is all up on GitHub, and you can take advantage of it, test it in our sandboxes, or even try it out in your own environment if you think it would be valuable. Be sure to join the DevNet community and take advantage of all the learning labs and sandboxes that are out there. And please stay in touch, whether you've got questions or just want to say hi. You can find me via email at hapresto@cisco.com or on WebEx Teams at the same address. You can find me up on Twitter at hfpreston. And be sure to follow Cisco DevNet on all the social medias at Cisco DevNet. Thank you so much for joining me for this video in the Network Programmability Basics video course. I look forward to seeing you in the next one.